You've probably heard a ton about these incredible new AI agents, right? The ones that promise to act for us, booking flights, managing our calendars, basically tackling our entire digital lives. But there's this massive hidden challenge that's really holding that future back. And it all kind of boils down to this question. For an AI to actually do something in the real world, like call a flight booking API, it can't just write a nice sentence. Nope, it has to generate a perfectly formatted, structured piece of data, like a JSON object, that a computer can understand. This is the critical and often fragile bridge between the AI's creative, sometimes messy world, and the super rigid, structured world of software.
And this leads us to the villain of our story today, the schema on read problem. You see, without the right tools, it dumps this huge problem right in the developer's lap. They're left trying to guess what the AI will spit out, writing brittle code to parse it, and just praying the AI doesn't decide to change its format on a whim. It is a constant source of what we call validation headaches.
So, to really solve this, we first have to get our heads around the foundational tech. Think of these as the building blocks that both of our tools today, Instructor and LangChain, use to tackle this very problem.
Okay, so on the simplest level, you can just ask the AI for JSON in the prompt. As you can probably guess, this is super unreliable. A step up from that is something called JSON Mode, where the model is forced to output valid JSON syntax. That's better, but it still might not have the right fields or data types you need. The real gold standard, and what all the modern libraries are built on, is function or tool calling. This is where you give the AI a strict blueprint, a schema, and it's been specifically fine-tuned to generate a JSON object that perfectly matches it. This is where the real control begins.
All right, let's meet our first contender, Instructor. Now, if we're thinking in analogies, don't think of Instructor as a giant, clunky toolbox. Think of it as a specialist scalpel, a precision instrument designed to do one single thing and do it exceptionally well.
The entire philosophy behind Instructor is really captured in this quote from their documentation. It's not some heavyweight framework that's going to take over your entire project. It's a lightweight library that's all about being transparent, easy to debug, and super simple to plug into the code you already have. So how does Instructor pull off this beautiful simplicity? Well, the secret sauce is its relationship with Pydantic, a data validation library that, honestly, millions of Python developers already know and love. All you do is define the data structure you want using a totally normal Pydantic class, and Instructor handles all the magic behind the scenes, turning that into a schema the AI can understand and validate against. Now, here is Instructor's killer feature. It's this incredible self-correction loop. Let's say the AI returns data that fails your validation rules. Well, Instructor doesn't just crash and burn. No, it automatically catches that error, feeds the error message right back to the AI, and basically says, hey, you messed this up, here's why, now fix it. It's a self-healing system that just dramatically boosts reliability. Okay, so we've seen the specialist scalpel. Now let's turn to the generalist's Swiss Army knife, LangChain. This is a huge, comprehensive framework that aims to give you pretty much everything you could possibly need to build a complete AI application from the ground up.
The core idea in LangChain is something called the LangChain Expression Language, or LCEL. The whole idea is that every little piece, a prompt, a model, a parser, is its own component, and you compose them into a sequence, or a chain, using this pipe operator. It's a really powerful way to build out complex, multi-step logic, but it is a very specific LangChain way of doing things that you have to learn.
For getting structured data, LangChain's best and most reliable method is .with_structured_output. You just chain this method directly to your model object. It's a nice, convenient, high-level API. But here's the crucial point. Its effectiveness is completely tied to the underlying model's native abilities, like tool calling. It's basically just a nice wrapper around those features.
Okay, so we've met the contenders, we know what they're about, now it's time for the head-to-head showdown. We're going to compare their philosophies, look at some code, and see how they really stack up. Really, the battle between these two comes down to a fundamental difference in philosophy. Instructor is a focused library. It's designed to enhance the code you're already writing by doing one thing perfectly. LangChain, on the other hand, is a comprehensive framework that wants you to build within its ecosystem, providing tools for every single part of the process. And you can see this philosophy play out right in the code. With Instructor, the approach is just so direct. You take a standard API call that you'd be writing anyway, and you just add one little argument.
It keeps your code looking clean and familiar.
Now compare that to the LangChain way. To do the exact same thing, you have to think inside its system. You have to create and compose 3 different LangChain objects, one for the prompt, one for the model, and then the final chain itself. Now, this compositional approach is really powerful, but it definitely adds more boilerplate and structural complexity.
This table really breaks it all down. Instructor just patches a client you already know. LangChain requires you to learn its special language, LCEL. But the critical, and I mean critical difference is in that third row, retry mechanism. With Instructor, it's automatic. It's built in. With LangChain, you have to code all of that retry logic yourself, and that is a massive difference in out-of-the-box reliability.
So after that showdown, the question isn't really which one is better. The right question is which one is right for your project and for your team. So let's break down how you can make that strategic choice.
Your decision really comes down to a classic engineering trade-off. Do you prefer a big, comprehensive platform that gives you everything, or do you prefer a solution you compose yourself from best-in-class modular tools? This decision framework should make it pretty clear. You should choose Instructor if your #1 requirement is the absolute highest reliability and control, or if you're just adding features to a project you've already started. You should choose LangChain if you're starting a brand new project from scratch and your main goal is to rapidly prototype complex, multi-step chains all within a single integrated ecosystem.
But wait, it's not just an either-or choice. There's a really powerful third option here, the hybrid approach. You can use Instructor to build these ultra-reliable, self-correcting tools for your most critical tasks. Then you can wrap those rock-solid functions up and let a LangChain agent orchestrate them in a bigger workflow. This way, you really get the best of both worlds. Rock-solid reliability at the core with flexible orchestration on top.
And all of this brings us to our final thought. Tools like these really highlight a fundamental shift in how we're building with AI. As the models themselves become more and more intelligent, maybe our greatest challenge isn't about creating more raw intelligence. Maybe it's about our ability to reliably harness and control it. That's the real problem these tools are trying to solve. And it's a question that is only going to get more and more important.